All right, so more trig ratios. So we looked at how to find the different ones in the different quadrants yesterday, and then we're going to start off here just determining the quadrants where the following occurs. Now, there are different ways to think through these things. I gave you a lot of space here because we're going to do some little quadrants. I actually want you to draw 3 under number 1. You may not always need to draw all these. I just want to show you a way to think about it. You can actually put it all on 1 if you want to, but then it can get a little bit confusing. In general, for whether these ratios are positive or negative, remember I gave that little mnemonic of all students take calculus, which means in quadrant 1, they're all positive. In quadrant 2, sine and its reciprocal, which is what? What's the reciprocal of sine? Cosecant. Those are both positive. Tangent and what? Cotangent are positive. Cosine and secant are positive. Okay, so that's what that means. Now, in what we're looking at here is just where sine and secant have the same sign. So I'm just going to look at sine and secant. And honestly, if you put it on the same one, then you have to write those 4 times because they both start with an S. You can't really abbreviate much more. But for sine, here's what I know. I know sine's positive here. What about in quadrant 2 for sine? Positive. And then here? Negative, negative, right? And then for secant, secant is the reciprocal of what? Cosine. Secant and cosine. Okay? So the mnemonic here, this deals just with the sine, cosine, and tangent. So you've got to make sure you know which ones are related. So secant has the same signs as cosine does. Well, here they're all positive. So secant here, positive or negative? Negative here, negative, and here, positive. Okay. So we are looking for when they have the same sign. So they have the same sign in which quadrants? Quadrant 1. So you're just looking for the overlap there. Does that make sense? Depending on how the question's asked, all you're looking at is the signage. And again, originally I put it all on 1, but then I had to write sine 4 times and secant 4 times, and that just makes it a little bit easier. And you could even, you can kind of shorten that yourself a little bit more, and whatever works for you, just as long as you can make sense of your own stuff. All right, so let's look at the next one. I'm not going to do the all students take calculus part of it, but I am going to do 2 of them. I'm going to do one for cosine. They're all positive here. One for cosecant. Cosecant is the reciprocal of what? Sine. So this is 1 over sine. And then it's all positive there. So I know that that's true for all of them. All right, so cosine, is it positive or negative here? Negative, then negative, then positive. All right, and then cosecant is 1 over sine. So this is positive and this is positive because sine is all students, right? This positive or negative? Negative, and this is negative. Okay, so what I'm looking for here is for cosine to be positive, it's positive right there. Cosecant to be negative, it's negative right here. And where do they overlap? Quadrant 4. Okay, everybody okay with that? Okay, and if you can combine it into 1 or some other way of thinking, that's fine, but that'll work every time for everybody, but I know you can sort of start combining things that make it work better for you. All right, so then tangent and cotangent have the same sign. So do I really need to do any work here or any thought process? What do you know about tangent and cotangent? They're reciprocals of each other, right? So are they going to have the same sign? Because the reciprocal didn't change the sign. So it's in all the quadrants. They have the same sign. It's not asking where it's positive or negative or anything like that. It says the same sign, and that's in all the quadrants. And then cosine theta and tangent. So cosine and tangent. So cosine, they're all positive in quadrant 1. Then this sign is only positive, so that means it's negative, negative, positive. Tangent is only other positive here, so those are negative. Now what I'm looking for is cosine to be positive, tangent to be negative, and where do they overlap? 4. Everybody okay with that? So you can figure out, because you're going to need to know if it's positive or negative in which quadrant so that you can do the next part of this. Yes? Yes. Okay. Odd. So here's what happened this morning. I had 1 and 4, right? And I went down to ask Miss Archer something. And then I was like, well, let me see what you have written down. And so she only had 1, and I was like, why? And I looked at mine, and I was like, oh my God, why would I put 4? That makes absolutely no sense. And I didn't even, I think because I was trying to put, I know that this isn't quadrant 4, but yes, you're right. Same sign, thank you. It's 1 and 3. Who knows? She could have had 1 and 3 for all I know, and I just saw that 4 wasn't on there. What? I don't know. Does that make sense to y'all? Good question. Now does it make more sense? Oh my God, I thought today was going to be a better day. That's what I get for thinking. All right, we all good now? Yes? Okay, so now we are given the sine and cosine of theta, and we're going to find the exact value of the other 4, okay, in simplest radical form. So we are going to start by drawing our triangle on the coordinate plane. Now, for this, all right, so I can figure out sine is negative in which quadrants? 3 and 4. Sine is negative in 3 and 4. Cosine is negative in which ones? 2 and 3, right? So sine and cosine are both negative in quadrant 3. Does that make sense to you? Okay. So that means that I know that my triangle has to be in quadrant 3 because my angle has a sine value and a cosine value that are both negative. You with me on that? All right. So here is my triangle. It goes like this. And then you can think of these a couple of different ways, right? Think of them with your x and your y and your r, which is important to understand, and your opposite and hypotenuse, which is important to understand because they all kind of go together. We know as far as x, y, and r is concerned, sine go with x or y? Y. And if this is not a unit circle, which it is not, if it is not a unit circle, then sine is y over r, right? And it's just y if the radius is 1. Cosine is then x over r. So you know where to put your values on your triangle. You can also think of opposite and hypotenuse because sine is opposite over hypotenuse. So this is 5 and this is 13. But you have to take care of your signs here. Your y value is a negative 5 and your radius is always positive. Okay, because it's the hypotenuse. Does that make sense to you? Your cosine is negative 12 over 13. So that's the x value, which this is 12, and I know that this is negative, over 13, which is adjacent over hypotenuse. And that's how you get your pieces on the triangle. Everybody good with that? Now, without worrying about anything that's happening over here, if I've got to find these other values without really thinking about my triangle even, which values can I get directly from just looking at this? Can I get tangent just from taking one of these and doing something simple with it? Yes and no. I mean, there's a little bit more work, but this basically I'm asking like which ones are the reciprocals of this? So what's the reciprocal of sine? Cosine, cosecant, right? Sine goes with cosecant. So this is 1 over sine. So I know what sine is. It's negative 5 over 13. So this is just negative 13 over 5. And since this is y over r, this is r over y, which is the 13 over the negative 5. All right, and then cosine is the reciprocal of secant. That's x over r, so this is r over x, which I can get from the picture, but I also just know it's the reciprocal of cosine, so that's negative 13 over 12. So then tangent and cotangent are really the only two that I need from the picture over there. And so tangent is it x over y or y over x? Y over x. All right, so that's going to give me a negative 5 over negative 12, which is just 5/12. You don't necessarily have to write the first one. I just want to make sure you know where it's coming from. Cotangent, if tangent is y over x, then cotangent is x over y, and that makes this 12 over 5. Okay. Easy enough? We good? All right, good deal. Cotangents. Thank you. All right, thank you. This is for you. Go at the end of the class. All right, so we've got cotangent is negative, sine is positive. So, cotangent is a reciprocal of tangent. Where is tangent negative? Remember, this is all students take calculus. So I know it's positive here and here, so it's negative here and here. Does that make sense to you? All right, and then sine is positive here and here. So which quadrant is my triangle going to be in? Quadrant 2. Okay, so this is in quadrant 2. All right, so I'm going to draw my triangle. And remember, you always make it perpendicular with the x-axis, never with the y-axis. Here is my angle. Now, this one's just a tiny bit different because if you, depending on which one of these two you put on the triangle first, your work changes a little bit. So I think I'm going to actually show you this 2 different ways to look at it. Because remember that these are ratios that get reduced, okay? We always reduce them all as far as we can. So cotangent, is that x over y or y over x? X over y, okay? And sine is going to be y over r. So let's start by putting cotangent on our triangle. It's the x value over the y value, right? So this is the 2 and the 3. Which one is negative? The 2, right? Because it's the x value. All right, so that's negative. Now, if I'm going to put the sine, I should be able to put it on the same triangle, but look what happens. That's the y over the r. Well, the y value, oh shoot, and I have to, there's a mistake on this. You need to also change this to 3, or it makes no sense. I already had it printed out when I was really confused as I was trying to do this one because nothing was working out. It's supposed to be a 3. But either way, still, that's supposed to be the y value over the radius. Well, the y value I have here is 3, not 3 squared root of 13. So I'm going to put that one on a different triangle. I'm going to put that one on this triangle over here. The y value, which is 3 square root of 13, over the radius, which is 13. Now, these are values from the same triangle. So why do you think I'm not getting stuff that matches up? Like, why wouldn't it just fit right on there like the other one did? Good, because we had to rationalize. So there's a couple different ways to look at this. If you put the first one on there, that's the simplest. It's going to make your life simpler if you choose to do Pythagorean theorem. You can also reason through it thinking, all right, well, if I'm supposed to get, I know this has to be a negative value, and if I'm supposed to get negative 2 over 3, and this is 3 square root of 13, what would this have to be in order to reduce to 2/3? What can I put over 3 square root of 13 so it would reduce to 2/3? 2 square root of 13, right? And these numbers work in the Pythagorean theorem, and it's all fine and great, okay? Because if I do these, it reduces to that stuff over there. Now, depending on how crazy the numbers get, it may not be as simple to reason through, and you could probably get yourself a little confused on that. I could just ignore this right here and do the Pythagorean theorem, but I'm afraid that some of you, because you may not have done square roots in a while, or even if you have, would do something crazy wrong on something simple like Pythagorean theorem, because you have to square something that looks like this. But is this a little bit easier to put in Pythagorean theorem? Yes, and it doesn't matter which triangle you use, and you don't ever have to set up both of them. I just want you to see that this is what's happening here, and why the trig ratios work, because they can look, the fractions can look different, but they have the same value. If I just take this so that I can solve for r, so remember that x squared plus y squared equals r squared. So this is going to give me negative 2 squared plus 3 squared equals r squared, and you probably already know what it should be and what would make sense, but So this 4 plus 9 equals r squared. So r squared equals 13, and r equals the square root of 13. And it's because this got rationalized here. But these two triangles, they are not congruent, but they are similar to each other because all of the triangles that would have the same trig ratios are going to be similar to each other. Whichever way you can, as long as what you have on your triangle works with what you have up there and it makes them true statements, it wouldn't matter which one you would use, okay? I think that most of us probably would go the simpler route this way. But again, what I did, and I don't even have a good reason for it, is that I put the sine theta on my triangle first. So I ended up with this one, all right? And then I knew I had to come up with this some way because I couldn't just put that on there. But if you had started by putting this one on there, yours would look like this. So again, if you put the simpler one on there, it's probably the easiest way to go if you have to solve for something. Any questions about that? Do you see how that works a little bit different than the other one? Same concept. It's just because we had to rationalize. All right, so now, even before all that, I can look up here. So we're just going to kind of ignore this one. Since I have both of them up there, it does make coming up with these a little bit easier, but I think most of the time y'all wouldn't have both of them, so we'll just pretend like this one isn't even here. Okay, not that it's wrong, but you're not going to have both of them to be able to just pull the numbers right off of. You have to do a little bit of work. So cosine of theta, it is not the reciprocal of either one of these, right? Cosine is it x over r, y over r over y? What is that? X over r. It is x over r, which is going to give me, my x value is negative 2 over the radius, which is the square root of 13. Right? And it makes sense that cosine's negative in the second quadrant. Then I rationalize, right? And so that's going to give me negative 2 square root of 13 over 13. Everybody good with that? Easy enough? Tangent, can I use the reciprocal of one of the ones I have? Yes, it's the reciprocal of cotangent. So this is y over x. So this is just going to be negative 3/2. And you're done. Secant, is it the reciprocal of something I already have? Yes, it's the reciprocal of cosine. Now, secant, so that means that secant is r over x. I can just pull that straight off the triangle. I can take the reciprocal of this cosine. If I did, would I want to take it at the end result or my original? Original. That way I don't have to rationalize. Just r over x is going to be the square root of 13 over negative 2. So it's negative square root of 13 over 2. Cosecant is the reciprocal of sine, so that is r over y, which if I take that, the radius is the square root of 13 over the y value, which is 3. And there are my values. Any questions about those? We all good? Yes. All right. Next one. Need to change this to quadrant 2. So it says, find the exact value of each of the remaining trig ratios of theta. We're doing the same kind of thing, but instead of having two different ratios and having to figure out which quadrant, we have one ratio and the quadrant, and then we have to figure out the rest. So here is my picture. Now, I know my triangle is in quadrant 2, so it's going to look like this. And cosine, I know, is x over r. Radius is always positive, so this is 3, this is 1. It's actually a negative 1. And then how am I going to find my y value? Pythagorean theorem. So this is x squared, which is negative 1 squared, plus y squared equals 3 squared. It's 1 plus y squared equals 9. Y squared equals 10. So y equals, technically, when you solve, anytime you solve, and you have something squared, and you're going to take the square root of both sides, every single time what you get is plus or, what is it? Oh my God. Yes, thank you. 8. It's 8, because you're supposed to subtract. Holy heck. I know, y'all lose faith in me every day. I know. She can't even add and subtract 8. All right. It's 8. Thank you. Oh, God. My brain was on the... So y equals plus or minus the square root of 8. A lot of times we just want the positive, but do we want the positive or the negative here? Positive here, but in some cases you might want the negative, right? But this is where it's coming from and why you would still get it from the Pythagorean theorem. Can I simplify this? Yes. What does that reduce to? 2 square root of 2. And it's the positive one is what I actually want for y. So there's my y value, 2 square root of 2. Yes? All right. And so now I've got to find the other 5. So I have cosine. I need sine. So the sine of theta is, and that is y over r. And so my y is 2 square root of 2. My r is 3. Can I reduce that? Nope. That's sine theta. I already have cosine theta. You don't always have to go in order, but consistency is good. Cosine's already there. So then tangent theta, that is what over what, just in general? Y over x. So that gives me 2 square root of 2 over a negative 1, which is just negative 2 square root of 2. Totally fine to skip that step right there if you know what it's going to be. I just want to make sure I don't lose anybody, because when you look down and write and look back up, you don't know where things came from. All right, so I've done sine, cosine, and tangent. Reciprocal of sine is cosecant. So that is going to give me r over y, which is 3 over 2 square root of 2. Can I leave it like that? Nope, I got to rationalize. So does this 2 really make any difference when I rationalize? Like, do I need to do anything with it? Or what do I multiply by? Just the square root of 2 over the square root of 2, yeah. So this is going to give me 3 square root of 2 over what? 4. And then I can't reduce that anymore. That's my cosecant. All right, we all good? Then my secant is r over x, which is just 3 over a negative 1, which is just negative 3. And then cotangent is x over y, which is negative 1 over 2 square root of 2. So again, I rationalize, right? And that's going to give me the negative, what? Square root of 2 over 4. Everybody okay with that? Yes? Had y'all gotten to these problems on your homework yet? Or not? Okay. So, does this help a little bit? It's good that you can think through them a little bit first. I'm going to give you a couple of more of them today, but not a ton of them. All right, so now I've got tangent, and we're supposed to be in quadrant 3. So it's down here. Tangent theta, I know, is y over x. So my y value is 2. This is 5. But what has to be true about them since I'm in the third quadrant? Both negative. That's why the little picture is very important. So then I get negative 2 squared plus negative 5 squared equals r squared. 4 plus 25. So r is square root of 29. Yes? So I'll start with sine. Sine theta, y over r. So that's negative 2 over the square root of 29, which becomes what? Negative 2 square root of 29 over 29. Makes it look even uglier, but makes it legal then. Cosine theta, x over r. So that should be negative 5 over the square root of 29, which is negative 5 square root of 29 over 29. If you can jump to that, that's fine. Tangent theta is 2 over 5. I already have that, so that's good. Then I can do cosecant. Oh my gosh. Cosecant theta. That's going to be r over y. That's nice. I'm not going to have to rationalize here. So that's a square root of 29 over what? Negative 2. Then secant theta, r over x, square root of 29 over negative 5. And then cotangent theta is x over y, and what is that? 5 over 2. Everybody okay with that? Make sure you can reason through what's happening on your quadrants. I'm going to start tomorrow, for real, not lying this time, giving you little quizzes on your values. So like, what is the sine of pi thirds and the cosecant of 2 pi over 6, things like that, okay? Not 2 pi over 6, because that would be pi thirds again, but whatever. So make sure that you're practicing those, because I did tell you you're going to have quizzes every day, and that hasn't happened. But hopefully you've actually been looking at them and practicing on them so that you can. And hopefully those will be pretty easy. But that's important to be drilling in your little heads, okay? We good? Any questions at all? Do I need to re-explain anything? It all makes sense to you now, kind of, yes? Okay, except maybe the velocities, but yeah, we'll come back to that again. Okay.